All right, hello everybody. This is not my typical video. I found something that I thought was really intriguing, a touch screen, a full, I guess it's 5-inch touch screen, 4 or 5-inch touch screen, battery charger. Now, I do a lot of playing with batteries. I have some 25R batteries back there and some Sanyo, some old reclaimed 2200 milliamp hour Sanyo cells. But I saw this, and compared to my existing digital charger here, which currently is charging Amazon nickel metal hydride batteries, which I'm normally happy with these, but the capacity seems to vary. This thing does a full capacity test and the numbers keep coming out inconsistent. So I had a failure during a live event and was unable to record on one of my devices. Now we always have a backup device, so there was a solution there. So I thought we would do an unboxing of this. It can do continuous current charging of 2 amps, I think per, so 8 amps total, 2 amps per cell. It says on the back here that it is a micro-programmed control unit, intelligent, constant current, constant voltage, DV control technology, color LCD, compatible with nickel metal hydride, nickel cadmium, lithium iron, lithium-ion, and it can do 3.7 volt or 3.8 volt nominal lithium-ion batteries. Fits rechargeable batteries below 26 millimeter and height 34 to 73 millimeter. So I think that means that it also charges the larger batteries, the 2100, 21700 or something, 21,700 instead of just doing the 18650s. Discharge current is set to 0.5 amps, but can provide up to 2 amps of charging per cell, I believe. Short circuit protection, reverse polarization protection, and automatic activation and temperature control and built-in cooling. So enough. Let's see what's inside this thing. This was, for me, this was $150 from a company in Florida. It appears these are made and sold on Alibaba and AliExpress, and if you buy them in quantities, they're something like $100 a piece. If you buy them in retail marked up, they're something around $140 a piece. So I'm doing a job of this. I understand that. I'm sorry. We'll put that there for now. So that looks like that's the unit. It looks like here is a, here we'll turn this around now. Okay, so here we are. We have a booklet, which we can go through in a moment. I'd like to plug the thing in and see how it works first. That's always fun. This is the unit itself. Okay, so maybe it's about a 4-inch touchscreen. Yeah, maybe about a 4-inch screen there. There is a IR test, a data port, a 12-volt port, a fan on the bottom. Max input is 5 amps, 12 volts. That's about the same as 8 amps at 4.2 volts. Close, not the same, but we've got a couple probes for the resistance test, because this thing will also test resistance of a cell. So let's get started in trying out all of this. Okay, the power sounded positive on that connection, and then plug it in. And what do we have? Let's get you an even more overhead view. We can move this out of the way. This is the center of our attention right now. So what am I looking at here? We've got a screen, which looks like it has a graph on it. There are 4 spaces for cells. They're huge. Here is an 18650 cell. This is a reclaimed Sanyo cell that I've already tested and is supposed to have around 2000 milliamp hours in it. I don't know the current state of this, so let's take a look. It says it is 83% charged, And I'm not sure what I've asked it to do. I think it's in charge mode. Okay, so let's do this one on a capacity test. That's pretty cool. So now it's going to start doing a capacity test on this, and you can see the yellow and red on the graph are, I believe, voltage and maybe current. Yeah, and it looks like it's currently set to 1 amp, which is fine for these Sanyo cells. Let's try a 25R and just see what it does with that. I'm not expecting anything out of the ordinary. I'm just putting it through its paces, that's all. So this cell is only 10% charged. I can tap on it and put it through a capacity test as well. Why not? We'll just start running capacity tests on everything. How do I get this to select that battery? Okay, so I can, if I tap on it once to select it and then tap on it again to bring up the test menu. Then there's a here's the current setting. So we have mode, current, and type. So this is a lithium-ion 3.7. We could change that if we needed to. So there's those two going. Let's try, this is an IKEA Lada cell. This is a nickel metal hydride AAA cell. I think it handles these. If not, we'll find out. So there we go. It says it's at 46%. This one is at half an amp. It should be at half an amp for that. It's a nickel metal hydride, nickel cadmium. That's great. Let's try a capacity test on that. I like capacity tests, guys. I really do. They're very good for testing, like, so when you want to put multiple cells in parallel. For example, this tall battery pack over here off to your left is a 13 series 5 parallel battery pack that I'm making for, or was making for, an e-bike, but I crashed the e-bike, so we've kind of put that on hold. If you're making a pack like that, the cells have to match, and one of the things they have to match on, besides chemistry and discharge and all that, is capacity. So if you're reclaiming cells like I do with all of these red Sanyos that I took out of laptop battery packs, you can get these down to about $1 a cell or less when you buy brand new, unsold, old stock laptop batteries that originally contained genuine cells. So then here on this, oh, I moved it and we lost it. Hang on. Try this again. There we go. 79% on the last one. We'll start a capacity test there too. It's okay with 1 amp, and it is a 3.7 volt cell, yes. So that's awesome. Let's see if I can, I don't know if this gives you a better view of the screen there. So, yeah, I think you've been able to see this. I don't have a monitor for the Osmo Pocket, so so there's a sort of a better view of the screen. As it's charging each of the batteries, it does kind of an animation too. So what I plan on doing, believe it or not, is putting this up in my studio here someplace, you know, back there, doing its tests while I'm doing my live streaming and recording and all that. And it'll be kind of a cool studio prop, as well as a functional, oh, I messed that up, as well as a functional item for my workshop here. Because this kind of thing is really cool. Now, how does this test thing work? They used USB leads. This is, I don't know about that. That's maybe cheap and a way to go in one direction, but at the same time, now you've got leads. You could plug this into a USB port, and who knows what happens when you do that and touch the ends together. I'm hoping nothing, but I'm not going to find out. So what happens if I press this? All right, so I'm in the middle of doing charging and testing and all that. I insert this here, and now I've got my 2 leads. Take the caps off the leads. That's nice that they come with caps. And then black is negative, red is positive, and there we go. 4.16 volts and 59 milliohms, which is actually kind of high. These are old cells, so I kind of expect them to be starting to fail. So yeah, there we go. 4.16, 59 milliohms. Let's try another one. here is another cell, 4.09 and 64 milliohms. And then let's compare that to a brand new cell. Let's get a brand new cell. I've never had these cells out of the box. These just arrived from, I think, Lithium-Ion battery supply, which, believe it or not, is near me in Pennsylvania. So that's really cool. And I got these for about $250 a cell. These are 2,500 milliamp hours and they're medium of the road discharge. Very reliable cells if you don't need the higher capacity chemistry. So this is a brand new cell right out of the box. What kind of numbers do we get here? 3.5 volts and 0 milliohms? What? Let's try this again. Yeah, 0 milliohms. 24 milliohms. There we go. 24 is a lot less than the others. Let's try the other cell and see if we get consistency. We should get consistency and get pretty much exactly 24 milliohms out of the other one. So this is a way to help tell the health of a cell. 3.51 volts and 21 milliohms. So very similar capacity, or very similar number there. Here, let's try it on a couple different cells. These, I believe these are the same or similar cell, but these are older, that I reclaimed out of I think a Dyson pack. 3.96 volts and 21 milliohms. So that might even be the same battery chemistry. And this one is 3.94 and 23 milliohms. So those are similar capacity. I think we can then press this and go back. I will unplug this for safety's sake, lest I accidentally use it to test something that's not a battery. And we can see how we're doing here. We have, does this graph get any bigger or anything? No, I don't think so. But you can see its charge pattern. You can see the voltage, charge pattern, voltage, charge pattern, voltage. There you go. So I think this is currently doing its charge up, and then we'll get to the discharge part of the capacity test. For that, I will set up a time-lapse thing. So that is the Efan Lux S4 touchscreen LCD charger. You know, I don't know if there's a protective film on this display, but I'm not going to try and peel it up to find out. So that is pretty cool. Yes, I'm entirely aware that you can get just as nice of a charger for $100 less if you don't care for a touchscreen. But this is pretty cool, and I think I'm going to use the heck out of it. I do a lot of battery testing and charging. So thank you for joining me, and I'll see you in the regular videos that drop.